Walking down the hair care aisle of your local supermarket, you might wonder why there are so many different types of conditioners. You might also be confused by the endless list of ingredients. Looking into the chemistry of conditioner could answer some of those questions. Before the advent of modern cosmetic ingredients, many people would simply use oils to moisturize their hair, which is a practice that still remains popular. Many plant oils, such as coconut oil, soybean oil, and olive oil, are full of molecular components called triglycerides. Triglyceride molecules have long chains of carbon and hydrogen atoms called alkyl chains, which have a fatty and oily feel. In addition to helping detangle hair by acting as a lubricant, these oils can help maintain the health of the scalp skin, which has a barrier of lipids and esters that helps keep the skin supple and moisturized. This barrier can break down due to diet, genetics, or environmental exposure, which causes water to escape in a process called transepidermal water loss. As the skin cells shrink, environmental irritants can find their way into the small cracks between them. The scalp absorbs the plant oils, which allows the skin barrier to be rebuilt and moisture to be retained. This alleviates irritation in dry scalp. However, there are many disadvantages to this process. Many plant oils have a high comedogenic rating, which is a number between 1 and 5 that measures how likely an oil is to clog pores and cause acne, with a higher number indicating a greater likelihood. Newer conditioners use compounds called fatty amines, which are nitrogen atoms that have long alkyl chains attached to them. They make hair feel soft and moisturized without clogging pores, and they act as a lubricant, allowing hair to be detangled. Fatty amines are primarily used because the molecules contain a positive electric charge on the nitrogen atom. Hair is composed of a protein called keratin, which contains a negative charge. Because they have opposite charges, they are attracted to each other. The electrostatic attraction between the fatty amines and the hair means that the fatty amines are able to cling to the hair during the washing process and between 8 and 24 hours after. Modern conditioners also often contain plant-derived additives to repair the skin barrier. A common example is panthenol, which converts to vitamin B5 once on the skin and plays a key role in repairing cells and preventing water loss. pH, which describes the acidity of a solution, is another important aspect of conditioner. Hair strands are coated in flakes of protein, called the cuticle, that either lay flat or raise up, depending on their environment. A flat cuticle is preferable for moisture retention, and if the cuticle is raised for long periods of time, it can start to break off and cause hair damage. The cuticle rises in response to a basic environment, which is defined by having a pH that is greater than 7. This means that it is important to create an acidic conditioner by using products such as citric acid. However, extremely acidic solutions will cause skin irritation, which means that conditioners need to strike a balance between protecting the cuticle and the skin. A pH that is able to accomplish both is 5.5. The primary ingredient in conditioner is distilled water, but many of the ingredients that we discussed previously are hydrophobic, meaning they repel water. In order to make a solution that won't separate, an emulsifier is needed. Emulsifiers form physical barriers that keep droplets from coalescing. They contain a hydrophilic head and a hydrophobic tail, so emulsifiers are attracted to both hydrophilic and hydrophobic compounds. The next time you pick up a bottle of conditioner, I hope you'll understand more about how it interacts with your hair and what the different ingredients do. But good luck pronouncing any of their names.